Thank you so much for obviously taking time out of your morning to have this call with us. Obviously, usually at Pitcon we do these in person, but 2020 has been a very different year. So obviously we've had to adapt and change how we do these. But hopefully next year, the year after, we can get back to Pitcon and we can do these in person and maybe interview in person as well.
Well, it's great to meet you virtually here.
Perfect. So can you define and describe an industrial laboratory?
Well, that's a great question, Michaela. So many industries don't have large industrial laboratories anymore, but certainly there's a rich tradition. If you go to Bell Labs, AT&T, and we in the energy industry have been fortunate to have large R&D hubs. Pharma and other industries have those as well, where they can develop new products and actually do some fundamental science. And so for Shell, we have major hubs in Houston, Texas, also in Amsterdam, and now in Bangalore as well. And in these hubs, we not only do the small-scale experiments, but also have bench apparatus, but then pilot plants and also development units that we need to be able to scale up our processes. So it's a very important aspect of our jobs and ability to do research, but also take it to commercial.
Perfect. Thank you so much. How essential is research into energy and chemicals, specifically analysis of its past, present, and future to the science and engineering industries?
Well, it's very important because, certainly the world is always changing and we're constantly developing new products to address sustainability issues such as climate change, the circular economy. And so it's very important to examine not only the targets, but how we're doing this research and how we can perform more efficiently. And so understanding the challenges, but also looking at how we're going about it and improving our methodologies and capabilities is a very important job for our industrial research labs.
Perfect. That leads very nicely into the next question. Could you describe the evolution of energy and chemicals research in an industrial lab setting?
It's a great question. I was looking at one of the Shell pilot plants from Emeryville during World War II in the 1940s, and it doesn't look that different in terms of pilot plant equipment from some of the units that we have today. And so when it comes to piloting and scale up, the processes look somewhat similar. But when it comes to R&D and some of the advanced methodologies, when that things like multi-throughput experimentation for catalysis, advanced in situ measurement devices, and et cetera, even robotics for catalyst preparations, we've moved quite a bit in terms of the experimental capabilities. So in a certain sense, it's somewhat similar to the past, but with a lot more instrumentation and a lot more high-tech equipment on the front end in order to accelerate our learning and throughput.
Perfect, thank you. So this year you're going to be presenting the Wallace H. Coulter Lecture at Pitcon. Your presentation is going to be titled The Industrial Laboratory for Energy and Chemicals, Past, Present and Future. Please could you tell us a little more about your work and what you're going to be presenting this year at Pitcon?
Well, yes, I'll be talking on those grand challenges in addressing climate change and sustainability and show a little bit about the strategy of the energy industry and Shell to address that. Also some deep dives in some of the examples we have in the past of using laboratory equipment and advanced methods in order to address some of those challenges and address the needs of speed to market that we have in research. So a few deeper dives into that, showing examples from my colleagues here at Shell, and then painting that grand picture of what those challenges are that the energy and chemicals industry needs to address going forward.
So your research covers novel chemical processes, oil recovery and biofuels. What are biofuels and their potential for solving energy challenges today?
Well, I think most people are familiar with the ethanol biofuel, which is made by fermentation. So our ricin business in Brazil is a world leader in developing ethanol from sugarcane as one example. But also I spent more than 10 years working on advanced biofuels, which is taking non-edible feedstocks such as food or plant waste, wood chips, also other landfill waste materials, and et cetera, and then converting them into advanced biofuels. So this would be fuels that you could use for aviation or your conventional gasoline or diesel. So certainly we've covered all of the above and many challenges in looking at their conversion.
Perfect. So obviously you've touched on how climate change is a big factor for the energy community and energy applications. How does the priority of sustainability shape the direction of your work?
That's a great question. So if I look back on my career, it's always been at the forefront of why we were moving in a given direction at the time. And I graduated from school during the energy crises of the 70s and 80s, and where there was an absolute lack of energy or worry about the availability. And so finding sources of energy for our customers and stakeholders was the drive of the day. And then we've discovered all kinds of forms of energy now. And so now it becomes a matter of selection and choices in terms of which are the most sustainable and which have the lowest footprint on the environment. They have to be delivered affordably as well. And then on the chemical side, just about all of our developments over the last few decades have really focused upon what we call the triple bottom line, or adding sustainability to the economics part of the equations, because that's what you and our stakeholders, the consumers, are asking for. And so when I look back at the developments that I've been fortunate to be involved with in chemicals, it's really been driven by delivering cleaner products to the marketplace with processes that take a reduced environmental footprint. Case in point, we formed a sustainability network in Shell in 1999. I published a book on the subject, and so it's been a major driver behind our innovation opportunities for multiple decades now.
So in July 2020, this year, you published some research at Hierarchical Clustering Decomposition Algorithm for optimizing renewable power systems with storage. Could you tell us a little bit more about this research?
Yeah, well, I have to acknowledge some of my young colleagues at Texas A&M University and the Energy Institute for doing some of the high-level mathematics with that one. But that really involves the intermittency of renewable energy. And so when one is trying to really optimize and look at an energy system with that degree of intermittency and complexity, it's very computationally intensive. And so that particular paper was about an algorithm so that you could group representative days of solar and wind availability, and then input that into a very large parameter model and actually generate a result within our lifetime of computation so that we could see the end result. So on the computational side, very important to be developing these advanced algorithms, because the energy systems problems that we're tackling are just enormous. And the good news is we can put together these very large parameter models and look at the optimizations across that system.
Perfect, thank you. So taking into account the case studies that you've told us about, your research from over the years and your time at Shell, what surprising obstacles have you faced during your research on energy and chemicals?
Yeah, I guess the major obstacle is actually the ability to predict the future. And so I've been amazed at how dynamic the energy and environmental sustainability situation has been over my career. You know, in terms of lack of energy to an abundance of energy, new technologies like the fracking and shale gas revolution that we recently experienced, deep water productions, and now the precipitous drop in solar PV costs, making renewable energy available, but also consumers changing desires and habits in terms of what they would like to see about the environment. Do we use the forest for biofuels? Do we save them and use other sources, and et cetera? Keeping ahead of those changes is certainly the big challenge. This last year of COVID being a good example of just a tremendous change and for all of us in terms of how we're going about our business and what we're addressing and what we need to do to go forward.
With COVID, how did you change? How did you adapt around that?
Well, we've had to go virtual in terms of a lot of our laboratory experiments and programs. And so basically, we're doing quite a bit of the Teams meetings and collaborations. It's been good for a company like Shell, where we are actually globally distributed in our resource base. So we're typically having expert conversations from 3 major different geographic zones across the world. We can also do remote monitoring of experimental programs, using our process control and database toolkits. And so you don't necessarily have to be in the lab anymore to really get a good hands-on feel of what's happening. And so those are all good things. I'm sure we've reduced our CO2 footprint from air travel quite a bit by using the new tools, and that's going to continue after this year, I'm sure.
Perfect. That sounds really interesting and good to hear as well that you were able to continue and it didn't put a stop to anything. Are you looking forward to virtual Pitcon this year? What new trends do you think it will bring?
Well, it's exciting. So again, I found personally I can attend a lot more meetings if I'm not traveling so much. And so that's one of the advantages. And it's interesting to be meeting people virtually. And but I've seen some very interesting things in terms of breakout sessions and abilities for people to subgroup and chat and network. And then also the advantage of having all of the presentations and the videotaping. So quite often, if you use it correctly, I think the virtual world, you can actually expand the number of different things that you can see and or retain because, it doesn't have to be in absolute time. And so you can do more paralleling and really perhaps cover more of the space than we could have if it were all face to face. And so I'm looking forward to it, and I'm hoping everyone else is, and hope to learn a lot of new ideas, make some new connections, and come join us and work on some of these grand challenges that we have in sustainability, climate change, and circularity.
Perfect. And the final question is, it's safe to say that 2020 has been a very different year compared to other years. Why are events like Pitcon important for the science community to come together now more than ever?
Yeah, I think, again, our challenges are greater than ever. And we need to stay connected in that regard. I find the networking to be just so tremendously valuable to keep in touch with not only what our opportunities are, but also what our stakeholders' interests are. And so that's very important to stay connected. And I think, planning to deliver these events, this is a lot of the communication of what our research outputs are. So I think these events help to drive the research communities in terms of, I'm going to show some of our latest results and here's some of our latest opportunities, equipments, and et cetera. So they become focal points for driving, what we're doing in our normal jobs, and then networking and moving it forward, as a community. So I certainly hope that the virtual aspect will not detract, and can we learn how to really have it be an advantage and do more of it into the future.
Excellent. Thank you so much, Joe. That was really interesting and helpful and insightful. And we're really looking forward to seeing your presentation this year at Pitcon.
Well, thank you for the opportunity, Michaela. So certainly looking forward to the event and the opportunities to network further. So thank you.